Stateless Autoconfiguration is a great feature for IPv6. It allows our end stations to automatically generate their own IPv6 addresses. Don't need a DHCP server, and you don't need to do any type of static or manual configuration on the clients. So you plug the client into the network, and they're going to generate their own link local address for their interface. That's an address that starts with FE80. They're then going to join the all hosts multicast group, and the reason why is because they need to be able to receive multicast messages that are going to that all host multicast group. Router advertisements are one of those types of messages. So the all host multicast group is FF02:1. They then generate their router solicitation message. However, if they've already heard the router advertisement from the router, they don't need to send a router solicitation message. So the router solicitation message is saying, hey, any routers out there? If there is, I need some addressing information from you. So the router advertisement sent from the router, and it includes the prefix the router is using on its interface that's connected up to that local area network. And then once the client receives that prefix, it can then generate the latter portion of the address. So the prefix is only going to contain the first 64 bits of the IPv6 address. And then after that, the MAC address can be used by the client to generate the interface portion, or a random ID can be utilized. Duplicate address detection, or DAD for short, is then utilized to determine if that IPv6 address that the client generated is unique for the local area network. And then lastly, the client says, hey, I received that router advertisement from the router that uses this particular link local address. So it sets its default router now to the IPv6 link local address of that router interface. So how does the interface portion get determined by the client? Well, once you receive the global unicast prefix from the router, the client, depending on the client, has different options. For example, a lot of the newer Windows deployments, Windows operating systems, use a random ID, a random generator that Microsoft has implemented. So they're just going to come up with some random value to fill in the latter 64 bits. However, there is an IEEE standard known as EUI64, and this is based on the MAC addresses. So the MAC address of the client, as we see down here, is going to be utilized. However, a MAC address is only 48 bits long. So how do we take a 48-bit MAC address and plug it into a 64-bit area? You have to break it apart. So you break it into two parts, 24 bits on one side, 24 bits on the other side. And in the middle, you fill the field with fluff every time. Fill the field with fluff every time. FFFE. That's the way I like to remember it. So whenever you see a MAC address, or an address, period, pardon me, an IPv6 address that has FFFE in it, that is an EUI64 generated interface portion of an IPv6 address. However, that's not the end of it. One more thing has to be done, and that is the 7th bit from the left gets flipped. What do I mean by the 7th bit from the left gets flipped? Well, let's just take the first two hexadecimal values of a MAC address. So let's say our MAC address started out as 0A, and then there was the rest of the MAC address. Well, if we convert 0 to binary, what do we get? We get we get 0000. If you convert A to binary, what do you get? Well, A is 10, so there's 8, 9, 10. So there we go. That's what A is in binary. So with that information, where is the 7th bit from the left? That's right, I said 7th bit from the left gets flipped. Well, 1, 2, 3, 4, 5, 6, 7. So we flip that bit. What's our new values here? We get 1, 2, 3, 4, 1, 0, 0, 0. So now we convert that back into hexadecimal. We have 0. And then what's the next value? It's just 8. So the MAC address has been modified, has been broken in half. We put FFFE, and then the 7th bit from the left gets flipped. So instead of it being 0A followed by whatever, then FFFE followed by whatever, it's now 08 followed by whatever, FFFE followed by whatever. So that's how EUI 64 works. However, it's really important to make sure that you understand that stateless auto-configuration only works perfectly if IPv6 routing is enabled on a router, the interface is enabled for IPv6 on the router, and the prefix the router is using on that interface is a /64. If it's anything but /64, it will not work.